Let's jump right into this explainer with a quick sense. Shalini sat next to a friend with toys versus Shalini sat next to a friend with toys. It's literally just one tiny comma, right? But think about it. That single mark completely changes who's actually holding the toys. In the first one, the friend has them. In the second, Shalini does. Missing or misplaced punctuation, it causes instant chaos in language. And guess what? The exact same thing happens in mathematics.
So, welcome to today's explainer, where we're going to discover how math is actually a highly precise language of its own. It's perfectly designed to eliminate all that ambiguity we just talked about, as long as we know how to read its grammar.
Here's our roadmap for today. We're going to start with the language of math, move into comparing expressions, tackle the ambiguity problem, learn about brackets and terms, and finally wrap up by mastering the rules of grouping.
All right, let's get right into part 1, the language of math, focusing on our basic vocabulary. You see, just like English has descriptive phrases, math has what we call arithmetic expressions. An arithmetic expression is just a mathematical phrase. Think things like 13 plus 2, 20 minus 4, or 12 times 5. And the absolutely crucial point here is that every valid arithmetic expression always evaluates to one specific number. Think of the equality sign like a bridge. It connects the expression 13 plus 2 directly to its evaluated meaning, which is, of course, 15. We simply read it as 13 plus 2 is exactly equal to 15. No confusion, perfectly clear.
Moving on to part 2, comparing expressions, but this time without actually calculating them. Imagine we've got two friends, Raja and Joy, and they're trying to figure out who has more marbles. Let's say Raja starts with 1,023 marbles and gets 125 more today. Joy starts with 1,022 and gets 128 more today. Now, you might be tempted to reach for a calculator right about now. But hold on, let's just look at the underlying logic for a second. Raja's total is 1,023 plus 125. Joy's is 1,022 plus 128. We can confidently say Joy has more without adding up those giant numbers. Why? Well, Joy gained 3 extra marbles today while starting only 1 marble behind Raja. Grasping the expression itself totally saves us from doing unnecessary busywork.
Which brings us to part 3, the ambiguity problem, and what happens when we're missing context.
Context obviously helps a ton, right? But what happens when an expression lacks that story? For example, someone named Malesh wrote this expression to calculate the total marbles he and his friend Arun brought to the playground. 30 plus 5 times 4. I mean, it seems simple enough.
Well, Malesh's friend Purna calculated 140. He just did the addition first. 30 plus 5 is 35, and 35 times 4 is 140. But Malesh, he got 50. He multiplied the 5 and 4 first to get 20, and then added 30 to get 50. So, who's actually right here? It's completely ambiguous just looking at those raw numbers.
Let's clear this up in part 4, brackets and terms, which is basically math punctuation.
There's a great saying. Just as punctuation marks are used to resolve confusions in language, brackets are used in mathematics to resolve confusions. Spoiler alert, guys, Malesh was actually correct. To avoid Purna's perfectly logical mistake, we use brackets to tell us exactly what operation we need to perform first.
By wrapping that 5 times 4 in brackets, the ambiguity vanishes instantly. It's a game changer. The brackets act like a giant flashing sign saying, hey, do me first. It tells us to find that product, which is 20, before adding it to the 30, giving us the indisputable, unambiguous answer of 50. But what if the brackets just aren't there? Well, that's when we look for what mathematicians call terms. Terms are parts of an expression that are separated by a plus sign. So, an expression like 12 plus 7 has 2 distinct terms, 12 and 7. And the rule for subtraction? It is actually fascinating. We literally convert subtractions into negative additions. So 83 minus 14 becomes 83 plus negative 14. By doing this, we create clean, movable blocks of math that we can evaluate totally individually.
And that brings us to our final section, part 5, the rules of grouping, where we look at order and flexibility.
I want you to think about swapping the order of things in everyday life. Putting on a hat, then your shoes, versus putting on your shoes, then your hat. The end result is totally identical. You end up dressed either way. In math, when we swap added terms around, like moving those blocks we just talked about, it's the exact same thing.
We call this the commutative property. The final value doesn't change, no matter which block you decide to add first.
However, we have to remember that order definitely matters in other situations. I mean, putting on socks before shoes, that works great. Putting on shoes before socks, yeah, things are going to get very uncomfortable. In math, doing operations out of order, like ignoring multiplication rules or evaluating brackets at the wrong time, is just like putting your shoes on before your socks. It completely messes up the final result.
So how do we keep it comfortable and correct? Because the associative and commutative properties allow us to group and swap additions so effortlessly, we just follow 3 golden steps. Step 1. Identify and evaluate the separate terms. Remember, that's things grouped by brackets or pure multiplication blocks. Step 2. Swap or group those evaluated terms safely. And Step 3. Add them all together for the final value, in literally any order you please.
To wrap up this explainer, let's actually put this into practice with a real-world scenario. Let's say 4 friends order doses that cost 23 rupees each, and they leave a flat 5 rupee tip for the table. Based on the precise grammar of math we just learned today, is the total cost 4 times 23 plus 5 without brackets, or is it 4 times bracket 23 plus 5? Think about what that tip really means and how the terms should be grouped. How would you confidently write the expression to split your next dinner bill? Keep that thought with you next time you're out to eat, and I'll catch you in the next explainer.